क्या लाइव जा रहे हैं? Okay, so welcome to the second live session for the integrated waste management course which we are offering this semester. As you know, this is the second rerun of this course, so this is the third time it is being offered. So as part of the online live session, what we do is first we look at some of the questions that has been posted using that Google link that you have been provided to you. So I'll go through those questions, then we have some of the students here as well today who will ask some questions. We'll go through that, and in between whatever questions you have, please go ahead and post it on the chat box, and we will answer as those questions come in. So in terms of the questions that we have here, there is two questions are pretty much identical. One is from Venkat Ramana Nalam and other is from Roshan Saxena, and both of them is asking question related to how to do a startup on waste management. So there's they have done some courses already. They are doing this course, they have done e-waste course and all that, and they wanted to start a startup on like a waste management, and they want suggestion from me, but I don't know, like I'm not a business person, I'm a technical person. So we are professors, so we can, but I can give you some ideas that in terms of course in waste management sector, it is upcoming sector in India. There is a lot of work which will come in this area with smart cities mission, Swachh Bharat mission, the government of India's different programs. There is a incentive to do something in this particular sector, and one thing especially for this sector as well as for any environmental related startup, you need a lot of patience. If you think that you will go into the sector and start making money in second year or third year, that will not happen. It takes time because these are basic infrastructure stuff. So it doesn't happen overnight. You need to first of all, you need to choose the right technology. If you followed this course, we did talk about how to go about choosing a right technology. Look at the waste composition, waste quantity. Based on the waste composition, you choose whether to go for composting, anaerobic digestion, thermal treatment. Then again, thermal treatment, you need to know the moisture content, calorific value. So those are the technical inputs that goes in there. In terms of the business side, you have to look at the revenue. How much money you will get in terms of getting that waste, which you can charge the tipping fee, and as well as what are the products you will make out of those waste, and the market, the local market availability. So there is no bullet, there is like no single bullet which can help you start go and start doing a business and start making profit tomorrow. It will require a lot of effort, and of course, we can talk about this forever and ever depending on where you are, what exactly you want to do, whether if you are in Kerala versus in Delhi, situations will be different. So I would say you go get started, best of luck for doing that, and if you need any help on this sector, you can always contact us. You know how to get in touch with us, and we'll be happy to help you. So the second question is from Uma Mageshwari, what are the Indian standards for smart city development? So if you look at the smart city website, there are 6 areas that has been identified, which one of the area relates to waste management, one area relates to water, there is area related to ICT, there is area related to smart mobility, there is this area related to health, and so on and so forth. So there are 6 major areas if you just go on a smart city website, and that areas has been discussed in one of the videos in the class as well, that what is a smart city program. So based on that, from this particular course perspective, waste management is 1/6 of smart city mission. In terms of standards, there is no as such kind of hard and fast standard. The way the smart city program has been developed in the country, there was a competition between different cities present which is there in India. So the cities were invited to give their proposal. So out of those 6 major thrust areas, they chose the area they want to work with. It's not that every proposal included all these 6 areas. So they chose some, if you look at the proposals, most of them actually did not do much on waste management side, because that they realized that it is a tough area to work, tough to make real very quick progress. So, they started looking at ICT, they started talking about mobility, they are making some flyovers and making something online. So, which are little bit easier, they are also not easy, but comparatively they are easier than setting up a waste management infrastructure. So, that's and then when you go about, so there was a proposal was submitted, there was a competition, internal competition, and within that the first 20 cities were selected, and now there is a gradual process of that. Many of those iteration has happened, and today we have more than 100 cities which are working towards becoming a smart city. So, but one thing you have to realize that when they talk about a smart city, it is not the entire city. For example, in Delhi, the smart city is only a little bit part of NDMC, New Delhi Municipal Corporation. In Ranchi, for example, which is the capital of Jharkhand, it is only the small area where at Dhurwa HEC, that heavy engineering corporation area, that is the smart city. In Kolkata, Newtown was only the smart city. Newtown already is pretty, I would say, relatively smarter than the other part of Kolkata, but now West Bengal government has decided not to participate. They call it a different name. Essentially, it's the same thing happening there as well, but under a different banner. So that's so those are, so in terms of standard, not even Indian standard. When you look at the global also, there is no hard and fast standard. There is no hard and fast even definition for what is a smart city. But one thing is very sure, that if you are, say, from an environmental standpoint, which I can speak from, unless you have a clean water, clean drinkable water, unless you have you don't have to put mask throughout the day to travel through what is happening in Delhi, for example, or other cities in India right now. So, those are not a smart city. So, those are they may have a tag of a smart city, but they are not a smart. A smart city should have clean drinkable water, should have no air pollution, minimal air pollution issues, proper wastewater management, proper solid waste management, and all those like IT and other stuff there as well. IT and other stuff is secondary. First is water, air and soil, that has to be cleaned up. Otherwise, what's the point of having a smart? Just putting computers and Wi-Fi is not a smart. That's computerization. That's a using of technology. But they are not smart. That's a digital. But that's part of the digital India, not the smart city mission. So that's that was first two questions were the same. So this was kind of question 3. Then question 4 is working with data and statistical method. Is it important for exam? What is the pattern for exam? Exam, you already know. There will be. I think we have mentioned that in the first live session as well. There is a typical way the NPTEL exams are conducted. You have to certain questions will be similar to what you see in the quizzes. Some questions will be similar to quizzes, but not exactly what was there. Some questions may be very much similar to what is there. Some will be kind of similar, but then there will be questions which will have which is there from the material or from the tutorial and other sessions that is out there, but we may not have directly solved that kind of problem. So there will be a mixture of multiple choice, true and false, and some math problem. So that's the typical way of these exams are done. It is totally online, like you have, if you have taken the GATE exam. So it's essentially the similar style these exams are conducted. So, and the last question from the online that Google Drive, what we have is, sir, I want a study material in PDF. Please provide me urgently. This is from Subham Kumar Shaw. The material is already there, so I don't know why you could not find it. So, but if you put it on, send us a message through discussion forum, we can send you the link from where to find it, but it is already there. If you go on weekly videos, after the video links at the bottom, I think that's where it is, at the bottom you will see the PDF for that particular week. So, you can download that PDF from there, and it so you should be able to find it. Unless still you don't able to find it, just let us know, and we will try to put you in the right page on the website. So, that's what we had from the Google folder. So, now we will get started with some of the questions from the students who are in this room right now. So, let's whoever has a question can raise your hand, and Anil.
Sir, my question is from biological treatment, and it's about C/N ratio. Why digested sludge has a low C/N ratio and yard waste has high ratio and newspaper has even high C/N ratio?
So, carbon nitrogen ratio, as it says, C/N is carbon nitrogen ratio. So, that depends on how much carbon is there and how much nitrogen is there. So anything which has high carbon relative to nitrogen will have high carbon nitrogen ratio. It's a ratio of 2. Total, you take the total mass of carbon, you take the total mass of nitrogen and put one on numerator, carbon on numerator, nitrogen on the denominator, and find out the ratio. Yard waste, say food, the sludge, if it coming from wastewater or even from the food waste, we have the sources. You have to look at the sources of the waste stream. If the sources has high nitrogen, say if you have protein, lipids and other things which has a higher nitrogen content, you will see higher nitrogen coming up there. Yard waste is predominantly carbon, so you see more carbon there, less nitrogen there. So it all depends. If you go to any animal based stuff, you will start seeing more nitrogen. Wherever you see a lot of animal related, animal waste, human waste, animal waste, more nitrogen, because what we consume, the food, nitrogen content is there, carbon content is also there, nitrogen content is also there. Yard waste is essentially mostly carbon. So that's why you see the nitrogen is less. So CN by ratio becomes your higher there. But in terms of both anaerobic, when you are in terms of biological treatment, we try to optimize the carbon nitrogen ratio to be around 25. It doesn't have to be exactly 25, but between 20 and 30, we try to bring it around 25 ratio. And why we do that? It's just to have. So carbon is what's the food the microbes will eat. Nitrogen provides them the strength to grow. It's like as we talk about in different classes or the videos, that it's nitrogen is the nutrient that is required.
And sir, what is the difference between static piles and windrows?
A static pile is where you have you can set up a yard waste and let it have the natural aeration going on. You don't do turning. In terms of general, they are more or less the same. In a static pile, you are not doing the turning. You let the natural aeration take care of your composting process. In windrow, you do turning from time to time. So that's the essentially difference between the two.
Sir, what are the major sources of dioxin emissions and its environmental implications?
So dioxins are predominantly coming from halogen based compounds. So if you have halogenated compounds, which like chlorine, bromide, all those stuff, that causes dioxin. So any waste which has halogen related stuff, so plastic do have those. That's why many times we hear that if you burn something with plastic, you will have chances of dioxins and furans. But then that's you have chances. Whether it will be in your emissions or not depends on how you burn it. If you burn it at around 1100 degrees centigrade and beyond, reaction you get that gets converted to gets actually burned to further to CO2 and other compounds. So it doesn't you don't form dioxins and furans. So that's why we say that in waste to energy plants we should try to keep temperature above 1100. Even for the secondary, the flue gas, if you remember, we had talked about that even you go even beyond 1100 just to keep these dioxins and furans low. In municipal solid waste, as we started using lots and lots of plastic in last 2-3 decades, dioxins and furans have become a bit of concern. Other sources of dioxin and furan could be there as well. So when you look at biofuel, anything which has chlorine in there, so you may have dioxins and furans showing up there if it's not incinerated properly. In terms of health application, health implication, it is said that dioxins and furans are potential carcinogen. They do cause cancer to certain organs of our body. So that's why that's the health implication related to that. And they can pass through the cells pretty easily. Yeah, please go ahead.
Sir, could you elaborate about beneficial reuse risk assessment?
So beneficial reuse risk assessment is we typically use that term when we are trying to use any waste material outside the landfill. Remember, if you remember that we use the term diversion. Diversion is we don't want things to go to the landfill. So we want to use it. So composting, anaerobic digestion, those things are treatment system. But if you want to take, for example, waste to energy ash, which we just discussed in the class as well. So you take the waste to energy ash and want to use it as a partial substitute for road construction. Now that ash could be used, could be used as a aggregate, the certain fractions of the ash. So, you take the ash, divide it into different fractions, pass it through some sieves. So, certain fraction could be used as a for the road construction. Now, when you go for road construction, what will happen? It is the rainfall which will percolate through that. So, we simulate a conditions in the lab where we have a artificial rainfall passing through it, and we want to see how much chemicals, inorganic as well as organic, will leach. Organic, anything with burning organic should be low, but if it is incomplete combustion, then you will have pH, dioxins and other stuff. But if you how much will go from the solid phase to the liquid phase? Why we are worried about liquid phase? Because liquid phase means it will go to the surface water. If there is a shallow groundwater, it can go to the groundwater. So, that assessment that is done to whether this particular waste can be used outside the landfill, that process is called beneficial reuse risk assessment, because you are trying to do beneficial reuse of that material. You are not putting it into the landfill. And risk assessment is basically finding out whether there is a risk to the threat to the soil nearby, to the water, whether there will be something in the air, so that we will inhale it, that we will become a problem. So, you do that protocol of risk assessment, which includes dose response, hazard identification. There are 4 steps for it. Then you look at how much the concentration, you compare with the risk based standard. You look at the surface water quality standard, soil standard, air ambience standard and all that. So, that is why it is called beneficial reuse risk assessment. So, we have some questions online as well. So, let us take that, and then we will come back to our students here for the further questions. So, there is Sharvanan Guruswamy. What is the basic idea for initiating awareness among public related to waste management? So, it is again basic idea for initiating awareness. This, as you probably are referring to that discussion where we said that waste management is not only an engineering solution, it is not only a management, you require a lot of social aspect here as well, because every day you are getting the garbage from people's home. And so, people's participation is on a day to day basis. Unlike sewage treatment, you go to the toilet, more or less it is the same, different, does not matter what you ate last night, it is more or less the content remains the same what comes out of the body in the morning, and our urine and other fecal matter. But in the waste, if people do not segregate, it becomes a problem. So, awareness is needed. In terms of initiating awareness, we have to tell people why the segregation is important, why they have to put the waste in certain bins, and how it going to impact your treatment system. So, unless you make, see, many times people are not aware, they think that why should I do that source segregation, what is the point of doing it? So, once they become aware that if they do not do source segregation, even a little bit of contamination can have lot of economic negative at the plant, then people will realize why it needs to be done. So, that is the way you have to go about talking to them, and this needs to be done again and again and again. I think in the video, in one video I do mention, also in the class I mentioned that it's, if you look at even big cities like Amsterdam, which has been working on waste to management infrastructure for almost 30 years now, they also struggle with source segregation some days from their high rise apartments, because we will have floating populations coming in, you have a big event in the city, and then there is a lot of people from outside came who has no idea how the waste is segregated there, because, and then you end up contaminating the system as well. We have Haider Khan, sir, how much questions from assignment will be there? I think it was what it's if you remember the breakup, if I have to, we'll try to see if we can put that on the discussion forum someday, but I think it's around 25, 50. So, 25 questions, then you can, I think it's maybe there on the NPTEL website. So, around 25 questions, which is similar to what you saw in assignment. It's not that exactly similar, but very much similar. Then 25 questions will be that based on assignment questions, and rest 50%. It's percent, 25%, 25% and 50%. So, that's the Faizan Ahmed. He has a question here which says, sir, do we need to analyze the gas being released during BMP assay every day for 45 days, or is it after 45 days? You do not have to do it every day during 45 days, and you do not do it just once after 45 days. you have to do at a regular interval. If you look at that map, that graph that we have in that first week lecture when we talked about the waste characterization for biological treatment, when we did that BMP test, you should do the analysis say after 1 day, after 5 days, after 15 days. So, you should have enough data points based on what kind of lab facilities you have, so that you can make that nice graph to get that 45 days data. So, you should have at least 5-6 data points in between. So, you can decide 1 day, 5 day, you can stagger it in a regular interval. So, 1, 5, 9, 13, then 25, then 35, then 45. So, you have to do multiple, not just one, because if you do it once after 45 days, you do not know when it started becoming flat. It may have become flat after 30 days. So, you do not know. So, you have to know. So, that is why you have to do at a regular interval and how the waste is degrading. Sir, is everything is related to life cycle analysis, then it seems like disposal is the only way for waste management. No, why you are saying that? It's so if you do the life cycle assessment, you have to look at like the whole picture. Life cycle is when you go from cradle to grave. Nowadays, even cradle to cradle, which is that circular economy. So, when you go for life cycle assessment, it does not mean that landfill disposal is the only way out. We always look for things other than landfills. In fact, if you look at your waste to energy lecture slides, you will see that waste to energy, actually even with waste to energy, the carbon footprint comes out to be half of that of landfilling. So, if you can afford to have waste to energy, if your waste is good enough for waste to energy, I would say you go for waste to energy, do not go for landfill, because landfill will be twice more harmful for environment than waste to energy. And of course, you should preferably, as you know, the 3 R's, 4 R's, 5 R's nowadays. 3 R is reduce, reuse, recycle. That is the first thing. Then recover, and you kind of get the energy out of that. So, there is a lot of R's are there which should be practiced first, then you go for composting and anaerobic digestion, and then finally, if you go for landfilling if needed for the residual waste. So, this is Rupesh Saini. How can we able to achieve more odorless water from STP plants? What is the cost involved in incineration plant? Incineration plant, we did talk about cost. If I remember correctly, it's there in one of the slides, I think $100 per ton, something like that. It's $80 to $100 per ton is the cost that's required for incineration plant. How you achieve more odorless water from STP plant? STP plant, if once odor comes from anaerobic system. So, after anaerobic, if you take your waste like a wastewater at the end, if you still there is a smell, you go through an aerobic system, you remove your those foul gases, and you can get. But I'm not sure why you are asking. What is the point of getting like odorless water? We should either we want a potable water from the wastewater, which will be all the ultimate. Basically, you go for tertiary treatment as well, and get very clean water, which you can use for any purpose you want. Even you can drink it, other than psychological issue. But usually we go after secondary treatment for basically surface runoff. We put it in surface water. We use it for spray irrigation and all that. So, that is where that issue. And if the treatment plant is working okay, you should not have much of an odor issue anyway. So, if that answers your question well, otherwise you can reframe the question and put it back to us, and we will look at that again. Again, Sarvana Guruswamy, he is like now one time we plastics are completely banned in Tamil Nadu. Sir, what are the other government initiative you think to reduce pollutant related to plastic? See, plastics ban, what you are talking about is the single use plastic ban, not the plastic ban, because the plastic we use from early morning to late night in different products and systems. Even right now when we are transmitting this to you, the wire, that microphone I have is actually a lot of plastic. All the cameras that is here has a lot of plastic. So, the TV has a lot of plastic right there. So, it's we cannot really live without plastic. That's the you can say, but plastic as a material is a wonderful material. So, plastic is not a problem. The problem is the plastic waste. So, once the plastic is used up and discarded, that becomes a problem. And there mostly the problems are your single use plastic, those thin plastics. The one single use means you used it once and you throw it away. So that's your single use plastic. Those that does become a problem, and those are being banned. Those are being banned at different places. Some places the ban has worked, some places ban doesn't work. The ban will only work when there is a replacement available for it, so that people can find something else. But many of those replacements are not also very great. If you look at some of the videos which are out there now, which says that the cloth bag, the thin cloth bag that you see in the market, which you get now with the in the place of plastic, actually has a very thin layer of plastic with inside. And that thin layer of plastic, when it gets in touch with water, it leaches off and goes into the water as well. And your Nescafe cups, all those paper cups has a thin layer of plastic there as well. So it's not that although it looks mostly paper, that doesn't mean it's 100% paper. So there are plastics, plastic being such a wonderful material, having a lot of application, will be there unless somebody comes up with similar material with similar price, and then plastic will go away. So what are the other government initiatives to reduce pollutants? So basically what the government and anybody related to waste management sector is to do is to develop the infrastructure, proper infrastructure. Banning plastic is only a one part of the solution. We need to have proper waste collection system, waste segregation system, and treatment and disposal system. So that's where the focus has to go. What would be a good case? This is a Dipankar Guha. What would be a good case study material related to social behavior change for integrated solid waste management? There have been some work done. You will not find this kind of you will find this kind of work mostly in social science journals, or some if you look at some thesis related to social and behavioral change associated with waste management, the humanities department people usually work in this area. But nowadays the government want humanities engineers all to work together, including economics. So that's having an integrated approach. That's why we call that integrated solid waste management. So there are social behavior is you do this. Someone was asking earlier that what we can do in terms of awareness. So you run an awareness campaign. You go out and run an awareness campaign and see whether the people have started behaving responsibly or not. You have to do the awareness campaign and again, and then you have to measure the impact. So those kind of case studies and materials are out there, and if you Google, you should be able to find it. Again, if you're not able to find, let us know. We'll pass you that information through discussion forum. There is a question again for Faizan Ahmed, sir. Elaborate ASTM DS23192. So it is it's essentially a standard test method for determination of the composition of unprocessed municipal solid waste by employing manual sorting. So it's manual. You can do the manual sorting and do the you can do some try to come up with a composition. So it's essentially to come up with a pie chart. So this is if you go to that I think in the waste composition lecture, where there is a picture of some students, and my picture is also there. We are trying to sort through the garbage and to do the manual composition to come up with the composition of the waste. So that's where that's the method that have been used over there. So that's kind of the questions we have from the online listeners right now. And so we will get back to our in-class listeners here and we can take some more questions from them. And anyone who has some question, please go ahead.
Sir, for any town which is having population of around 10,000, after collection of waste, how it can be managed?
For a town
having population of 10,000, around 10,000.
10,000 is a less population. 10,000
so
is
how we can manage that waste?
So 10,000 these days, even you will find some villages in India which has some big villages in populous states. You will find around 10,000 people. So 10 million would be a big city, which is closer. Say if you look at I think Ahmedabad, Kolkata, depends on how you define Kolkata. If Kolkata is just the Kolkata part, then it's maybe around 5-6 million. If you go beyond that, and if you include Howrah and all those surrounding areas, that will be more than 10 million. So 10,000, so if you look at the 10,000 population, again the steps will be the same whether you are looking at a small area or the bigger area. This steps is the same. First of all, you need to know how much waste is being produced, and any facility that you design it for a design life, isn't it? You have around we when we talk these subjects in the class and other, you have 25-30 years of the design life. So you do the population forecasting for those 25-30 years. Then based on that you come up with that at the 30 years time how much waste I will have to handle. In between you assume that whether the waste generation rate right now from the CPHO manual is 0.6 kg per person per day in urban area and around 0.35 kg per person per day in the rural area. So if it's something in between, you will take the value something in between. You have the population figure, and this number whether it's 0.35 will stay throughout 30 years? Probably not. That numbers can also change based on how the GDP of that area changes. As if you have remembered from the class, we have seen that higher the GDP, more is the waste produced. So you have to make an approximation there as well. So based on those, you will come up with the waste quantity. Then you will work on waste quality, like composition. Like one of the student was asking that how to do the pie chart. So you can, there are ASTM method there where we talked about in the class as well, to how to get that pie chart. How much paper, how much plastic, because that's the basic requirement. Like when you go to a doctor has to do certain tests to find out what is the disease. So similarly here in the waste management, you have to find out what are the different how much paper, how much plastic, how much those. So that kind of gives you an idea of what kind of treatment system you can choose. You look at how much is the biological component. If biological component is higher, and then you go for compost. If it's a 10,000 means semi-urban rural area, you can go for a compost plant. Or if it's in a big cities, you go for anaerobic digestion. So and then rest for 10,000, you will not have enough garbage to go for waste to energy plant, because it's a amount of garbage for a waste to energy plant. We talked about that around you need around 300 tons per day to really run an effective waste to energy plant. So, but so you can go for composting, you can go for recycling, and make that's the way you need to set it up. So find a place, look at 30 years. You also have to look at that how the waste will change over 30 years. Waste may not stay, because we get newer products. These days every day you have new product coming up. So that's that's also there. Can biodigester be an option for septic tank? So yes, septic tank is not actually 100%. Septic tank does have it's not like an airtight container. Septic tank does have option of going aerobic, anaerobic both. So biodigester can be an option for septic tank. I think you are talking about that can we use the human fecal sludge, fecal matter in biodigester? The answer is yes, you can use it for biodigester. You can produce gas from there, and you can use it for energy and other purposes too. Then Saket Kumar, he talks about the direct burning of waste at any waste disposal site may cause lots of air pollution. So can it used to reduce the volume of waste at site? Of course not. That's a big problem. Open burning of garbage is a huge problem, and that creates a lot of if you followed the news what is happening in Delhi, that is also kind of open burning of agricultural waste. That is one of the issue, not all the issue. We have farmers in neighboring states, they are after harvesting, they have those what we call stumps, or that root area which is half inside the soil, half outside the soil. So they want to get rid of that, and it's difficult to manually do it. There are few machines are out there, government gives them machine, but there is not enough machine, there is not enough government support. So what they do, they start burning it, because that becomes the cheaper option for them, but that causes a lot of environmental air pollution issues, not only for them but all around that area. Open burning of garbage also we see all the time in many places. They just trying to reduce the volume, but those are totally no practice. We should not do that. It's not you can do the incineration, you can do the thermal treatment of the waste or the incineration of the waste, which is in a incineration plant in a controlled environment with air pollution control system, not for in a open burning. So that's not allowed. So that's any other questions here from the students, or No questions. So what we will we'll if there is anyone online having any issues or any questions to raise, we let us know in the next few minutes so that we can answer that. Otherwise, we'll call it a day. But again, this is your last live session before the exam. So make sure you prepare for the exam well. Those of you who have registered for the exam, I would say don't worry too much about what type of question, what this and what that. Just go through all the assignments that you have done. Go back and look at the assignment, look at the solution of the assignment, go through, there are some tutorial sections out there. I think there are 3 tutorial videos. If there are, there will be, the 2 is already there, 3rd will be there soon. So you can look at those tutorial videos, and that will help you to prepare for the math questions. And for theory questions, going through those slides, going through that video is good enough. So if you are following weekly videos, you are doing the assignments well, you should not worry too much about exam. Exam is, it's not difficult, don't panic, just take your time, do it slowly, and you will be okay. And you have enough time to solve those questions. Any questions? Yeah, go ahead.
Sir, my question is about the TCLP test. Like we have assuming a dilution factor of 100 times when the leachate goes below the soil. We know that this is not the exact method, like it's just an assumption of 100 times dilution. Then why do we still accept it?
So TCLP, as you know, it was developed in late 1970s. TCLP, the full form is toxicity characteristic leaching procedure, and the test was developed to see that if a waste goes to a municipal solid waste, whether it will leach contaminant at a level so that it can potentially go down in subsurface if the liner is broken and go and contaminate the groundwater below there. So when the people who were developing the test, they had to make certain assumptions. So one thing, there were certain assumptions made, and certain things are, so for example, if you look at the TCLP, you take 100 gram, that's what the tells 100 gram of sample, you size reduce it to less than 1 centimeter. One of the diameter has to be, one of the dimension has to be less than 1 centimeter, so that it can pass a sieve of 1 centimeter. And you take 100 grams with 2 liters of solution. So again, there is a dilution of 1:20 right there, because but if you took 1:1, you will not get enough liquid to analyze. So that's why we use that 1:20. And you take that solution, and whatever goes into the liquid phase is that what we are worried about, because that will go and percolate, potentially percolate in the subsurface. Now coming to your question, that 100 liquid to solid, 100 ratio that has been taken, that 100 ratio was taken assuming that the drinking, whatever was the drinking water standard, that was multiplied by 100 to make the TCLP standard. So that's what essentially you are referring to. That's why, other way, that's the dilution. So if when it goes and hits the groundwater, the concentration in the groundwater is, say, for example, for arsenic, the concentration in the groundwater at that time was that it should not exceed 50 micrograms per liter, because that's the drinking water limit for arsenic. Today the drinking water limit is 10, but TCLP limit is still 50, is still 5 milligrams per liter. So they took that 50 micrograms per liter, multiplied by 100. The 100 was chosen assuming that if there is liner break, it will pass through that clay. So there is a 2 feet of clay in municipal solid waste, 3 feet of clay in the hazardous waste landfill. Then again it will go down, maybe the groundwater is 30 feet below, 40 feet below, 10 feet below, whatever, 15 feet below. So while it is traveling through that subsurface soil, arsenic will start reacting with the, whether if organic matter present, different binding site. Something like arsenic reacts very well with iron. So they will reduce the concentration of arsenic to around, make the concentration to be 100%, 100 times diluted. So that's the, say that TCLP always gets that criticism, why 100? Because, but if you think that those people who were sitting in that room like we are sitting today, they had to make some assumption, because they had to start somewhere. So that they chose 100. So there is, for 100, there is, I would say it's kind of guesstimate, you can call it. It's not entirely, there is some science basis there, because there are a lot of reactions happening, but there is also 100 is a easy number to work with. So that was, it was multiplied by 100.
Then
and
why there is no modification until now?
What is that?
Why there is no modification until now?
There is, in terms of in the lab, people have, if you look at the TCLP research, people are criticizing TCLP for some of the reasons that you are highlighting, and some of other reasons too, like there is no biology in TCLP. Municipal solid waste has a lot of biology going on, there is no biology component, but anything biology takes time. BOD test itself, we did it for 5 days. So when you go for biology, it's a time consuming process. So we go for something which is simpler. So it's all, but TCLP, that's why we say TCLP is a screening test. If you remember in the class, also in this NPTEL video, I keep on telling that if something passes TCLP, doesn't mean that that waste can be used anywhere and everywhere, because it's just a screening test. Once it passes TCLP, still you have to do, if you are doing it outside landfill, you have to do that beneficial reuse risk assessment protocol and all that. And there is a provision going on in terms of revisions of TCLP test. So if you look at now, there is what is known as the EPA has come up with a leaf test, leaf index, there is a that leachate evaluation and something, that's a leaf. If you go on Google, put EPA leaf, you will find that. So that leaf is kind of going away from TCLP and having a more realistic risk assessment. But in the lab, in the field or the lab, what we do, if even with something passes TCLP, we do a simulated columns. We put a simulated landfill in the lab and try to test whether it works there well or not. For example, something like lead, it leaches a lot in TCLP. Even Barbie doll comes out to be a hazardous waste. Those kids with the walking shoes, with the shoes make those sound or the lights because they have a small chips, that comes out to be a hazardous waste. We know that that's not a hazardous waste. So those are the shortcomings of TCLP. So when you do it in a column test, so this TCLP is a batch test. From batch test you go to a column test. From column test you go to a pilot. So when you go to a column test and put an anaerobic condition, because landfill is anaerobic. So TCLP test is mostly aerobic. That is also one problem. So TCLP test has a lot of problem, but again that was a screening just to find out what is the danger or not. So that's a screening test. We have to very much careful that something passing TCLP doesn't mean it's safe to use anywhere and everywhere. Rupesh Saini, is twin pit sanitization system suitable for high groundwater level areas? Answer is of course not. Also not applicable where there is frequent flooding. So in the twin pit he's talking about. So that's it's similar design is being done for the Swachh Bharat Mission toilets and other stuff. So if you start looking at, there is a criticism of that the Swachh Bharat toilets are becoming more of a point source from a non-point sources earlier. So it's not suitable. If you have a flooding, you will have those issues. Yeah. So that's what I already answered your question. This is Rupesh Saini. This twin pit arrangement is being constructed widely by government in rural areas. So yeah, that's essentially it becomes a problem in the areas where the groundwater table is pretty high, where we have high groundwater table. So this is not really, this may create problem because you will have this sewage getting into the groundwater if it seeps through. And we will, so that's as I said earlier just now, that it's essentially becomes from a non-point source pollution to the point source pollution. There has been some studies where people have shown that we have issues of things like sewage getting into the high say in groundwater in some areas. So that's why there is no one size fit all solution. That one toilet design is not fit for entire India. But sometimes when you have some certain programs, we go and do things as one size fit all, but that doesn't work like that everywhere. Yeah, please go ahead.
Sir, in anaerobic treatment, it is said that the methanogenic and non-methanogenic bacteria should be in a dynamic equilibrium. I mean, why is it so important that even non-methanogenic bacteria also should be in an equilibrium?
So if you look at the anaerobic digestion, there are 4 steps. You have the hydrolysis, acidogenesis with a D, and then acetogenesis with a T, and then you have a methanogenesis. So if you have two reactors, in one first reactor you are going up to the acetogenesis, where you are making the acetic acid. So that acetic acid, then you feed it to the second reactor. So your non-methanogens are in the first reactor, methanogenic bacteria is in the second reactor. So non-methanogens are producing the food for the methanogens bacteria. So that's why we say that they have to be in dynamic equilibrium, so that whatever food is made here is being consumed by the next. Otherwise what you will have excess of food, If the non-methanogenic bacteria is too active, methanogenic bacteria is dull, so you will have excess of food. On the other way, if the methanogenic bacteria are active, but this is not able to produce that food, no, methanogenic bacteria will starve and they may die. So that's why we need to have a dynamic equilibrium between the two. Sanket Kumar sir, in CND waste lots of iron present. So, present of iron can reduce the effect of lead and arsenic in hazardous waste. I am not sure. The lead and iron does lead and iron. So, yeah, lead. Let's talk about arsenic first, which we just talked about a few minutes back as well. Arsenic does have iron oxides, iron plus 3 state actually acts as binding site for arsenic. So, arsenic goes and binds with iron, and that is there. So, it's a, but once the iron reduces, arsenic loses its home and arsenic will come out. So, we have to make sure the arsenic or iron does not get reduced. Iron and lead also has a competition. What we have seen from an in terms of the chemistry, higher the iron present, with the higher iron present, less lead leachability, and with less iron, more lead comes out of solution. So, to answer your question, in CND waste, if we have iron present, it does help in, it will help in keeping arsenic as well as lead in like a solid form rather than getting into the liquid form. But if iron gets reduced, then they will lose their home, and then things will start coming into the liquid form. So, yes, iron will help lead, especially lead and arsenic, to not become hazardous waste. It will pass TCLP actually, and we have seen that in some of the, for lead we have seen it with electronic waste, and arsenic we have seen with some of the arsenic arsenic containing waste as well. So, let's see. Yeah, please go ahead.
Sir, can you elaborate about the pyrolysis?
Pyrolysis is it's kind of opposite of your combustion. Pyrolysis is done in the absence of oxygen. So, usually when you are for incineration, what we are trying to do is we get the heat. We are interested in the heat that is produced, and we use the heat to produce either steam. You can use the heat directly as well. Some countries, some cold countries in the world, they use the heat for their home heating system. So, for example, we are sitting in this room. If we are in Norway or other countries which gets really cold, these kind of rooms are heated by the heat coming from a waste to energy plant as well. That's called district heating system. So, that's the for the incineration, and that's an oxidation process. Pyrolysis is done in the absence of oxygen, and there our goal is to actually produce different product. You can produce char, you can produce different types of oil, you can get some you can get some gas, and then you convert that to value added product. So, it all depends on like what you want. Pyrolysis typically is done for a particular type of waste. Like if you can do pyrolysis on tires, you can do pyrolysis on certain even plastic pyrolysis is being done as well. Incineration, as we know, for the waste management, it's typically done for a mixed waste because you have you are just burning them, or mass burn or RDF. So, incineration typically when you are going for energy, pyrolysis is when you are going for products, and those products could be used to produce some energy, but there are some other things like char and other things are also produced. That's okay. Okay, so Ayappa Changam Reddy, negative marks are there in the exam. People are so much worried about exam. There is no negative marks in the exam, so don't worry about it. So, I think we have used up the time. That was pretty productive, a lot of questions. So, thank you, and all the best for your exam, and I'll probably see you someday in some other course as well. Thank you. This was better. In between, when there were no questions, you can ask question, or Anil के कुछ questions भी cover हो गए. Question ढूंढ रहा था वो. Good.
जो चैप्टर मुझे बायोलॉजिकल ट्रीटमेंट का पढ़ना था वो मैंने